Okay, let's try this again. Fine. I think. Okay, now the voice is audible. So students, just give me a second. Yeah. So hi guys. Sorry about the disturbances that I forgot some issue. Okay. Anyways, so welcome to the channel, and we are going to in today's class we are going to discuss about the questions which is asked in TCS NQT. So TCS has so many exams, but we'll be focusing on NQT parts. So in NQT parts, we have usually you'll be getting three coding questions. So three coding questions, and the time allocated will be 90 minutes. And then the difficulty, if you talk about the difficulty level of those coding questions, let's say the difficulty is going to be easy and medium level. So rarely we'll get hard level questions, but most of it's going to be easy and medium level. So yeah, as you can see, I've just pasted, and you can see in the screen, you can see that there is one of the questions, an example question that might be that have been asked in the like okay, fine. Anyways, so yeah, just have a look at the question and just try reading through it. So once you have an understanding, once you understand the question, like half of the solution is already done. Okay, fine. So let me just read out the question so that you will have a clear understanding. So you're given an array of numbers and the length of the array. So you can see that the input consists of array of numbers and followed by length. And a teacher comes in and asks you to find the first index at which the number k appears in the array, which means you need to find a number which is appearing in the array. Not only like you're not just finding the appearance, you're trying to find the first appearance. For example, like we have these array data. You can see these array data, right? So we have 1, 2, 5, 5, 5, 56, and followed by 78. And now followed by k data. So k data is given over here, which is going to be 5. So like 5 is occurring for 3 times. We have index values, right? We know what is an index value. So index value always starts from 0. So this is going to be 0th index followed by 1, 2, 3, 4, 5, and 6. All the index value. So you can see that 5 is occurring in second index, third index, as well as in fourth index. We need to find the first occurrence. So first occurrence of 5 is appearing in second index. Done. That's the objective of the question. Now, if not, there is another conditions, because most of the people will go for this particular, will read this one, and they'll forget the next important point. The next important point says that you need to print -1 if there is no such possible solution. No such possible solution in the sense if 5 is not at all present. Let's say in the array given, the given array, 5 is not at all present. So if 5 is not at all present, like we need to print -1 in that case. That is like in all the programming languages. If the not no solution is not possible, we'll be writing -1. Okay, next. And the next we have a note. So note says that the array is sorted. So we don't need to worry about sorting the array again. So the given input is already sorted. So these are all the information that we got. We got just give me a second. Okay. Now, so the three information which was given is we have array followed by k data, and then it's already sorted. And if no solution is possible, we are supposed to print -1. And then after this, you have two examples. We got first example over here, and we got second example over here. You can see over here, we got the second example. And now the most important point that you need to take care is if the time complexity information is given, then you need to do the program according to the complexities information, because it says that complexity is supposed to be O and log of n, which means that you need to write the code which runs like that. You cannot just go for linear search. You know what is the linear search, right? We'll be searching the data one by one according to the index values. That will take the time of big O of n. So, but in the question they mentioned you need to go for n log n. So basically, we are trying to search for a particular data, and we are trying to search not only the data for the first occurrence. I mean, the first index, like wherever the first index, the data is present. And space complexity is O of 1. O of 1 in the sense you can just use a single variable. Now, when it comes to search algorithms, okay, let me just make this as comment. Fine. So we got an understanding of the program. Okay, fine. So search algorithms, we have basic two search algorithms. So one is called linear search. Linear search works in we go of n, and we have the other search which is called binary search. So binary search is going to work. Binary search is going to take the complexity of n into log n. So which means that they mentioned the complexity is supposed to be n into log n, which means we need to go with binary search. Okay, let's start reading the input. So reading the input, it says that you don't have array size. They did not mention any array size. They just told array elements followed by the search. So if you want to read the input, let's say, usually how will we read an input? And that input supposed to be stored in a list, because like Python programming, right? So everything supposed to be stored in a list. So let me just create a list called L, and then start reading your input. So I'm going to read my input, and then split this input. Why am I splitting it? Because of different data. Different data will be given with a space in between. So these datas, if I do this, by default, it's going to take the data as a string data type, because by the default data type in Python, it's going to be a string. So we need to map it into an integer, so that all the input which is coming in will be splitted accordingly whenever the space is given. So if I give 1 space, 2 space, 3 space, and 4, all 4 elements will be stored in form of list. So now, after this, I'm mapping into integer, and this I'm storing into a list, which means again we need to cast it into a list. So split input, take all your datas, and then mention the data type, or like map it into the data type. The data type that I'm trying to map is into an integer, and then I'm taking this as the input, which is called L. So this L contains all the input data. Like as given in the input, we got 1, 2, 3, 4, 555, 56, and 78. So let's assume those are going to be our input. So for those input will be stored in L. And then we got K element. So K equals, this is going to be an integer. We need to cast it every time to an integer, because if it is a string or character, you don't need to worry about it, because by default it's going to make it a string. But in this case, it's going to be an integer. So which means cast it. So fine. So input of. So I'm not going to split anything, because K is just a single variable. So single variable stored in K, but L is a list. So once this is done, you can code it in the same. But usually when it comes to TCS, sometimes you need to write the code from the scratch. You need to read all the inputs, and you need to write this code from the scratch, which means you need to write the input, and you need to call for a method or a function, and that function you need to return the solution. But sometimes what happens, only the method name and the input will be given. All you need to do is find the solution and return the output, like return the solution according to the question. So now in this program, I'm just typing it from the scratch. So let's call for a function called solution. So in this, we need to pass some data. So the data is required in order to solve the program. So first I'm going to pass the list that I've created and then followed by the k data. So these are all the two data that is needed for this program. Now, let me define this solution and get your data. So I've passed L and I'm passing K. Done. And don't forget about indenting. So make sure your indentation, like press tab once. Don't go for clicking on space. That doesn't work because some IDE will provide, like for this IDE, I'm just giving a colon and I'm pressing enter, so it just goes to the next line. But some IDE, what happens when you click on enter, it will start the cursor from the beginning. So in that case, don't click on just spaces because that is going to throw an error called indentation error. So like most of the students does mistake in this one. So press enter. If the cursor starts from the beginning of the line, in the sense, all you need to do is press tab once. Just go with tab because that will make your, like the chances of getting error will be less if you do this. Now, fine. So binary search, already we know how binary search is going to work. We know we need to split the array into two, and will be getting left side and will be getting right side. So again, we need to search whether the data is present in the left side or data is present in the right side. Again, that if the data is present in the left part of the subarray, again, we need to split that into two. So for example, let me just take these inputs. Let's take these. So this is a comment. So I'm just pasting it. So this is my entire array which is coming in. And the k data which is coming in is going to be 5. Simple. Done. So now what happens? Binary search. If you can remember binary search, recall it. How to do binary search? We need to find the mid value. And if the search element is lesser than the mid value, then we will go for left part of the subarray, if not right part of the subarray. So initially declare the variables that is required. So let me keep two pointers in the sense, let me call it as left pointer and then another pointer for right. So left is going to be start from 0 and the 0 in the sense it's a left pointer. So it's going to start from 0th index. And we have another pointer, right pointer. Right pointer is going to start from end of your index. So left is pointing towards the data 1, and the right is pointing to the data 78. So how can you get it? Simple. So the name of my array is list. So list dot get your length of L. So length of L give you the entire size of your list. Minus 1 will give you the last index data because index starts from 0. That's why length minus 1. So left and right is done. Now what you're going to do is until these 2 point reaches the midpoint, because left is at 0 and right is at the last index. Left is at the data 1 and the right is at the data 78. So until these two data reaches the midpoint is going to be, let's say this 5. This is my midpoint. So until these two data reaches my midpoint, left index will keep on incrementing and the right index will be keep on decrementing until you get the middle one. So likewise, we're going to search for every data, whether the data is present or not, whether the data is not present, likewise. So anyway, now after this, I'm going to learn a while loop until I reach my midpoint. So left is less than equal to right. So as of now, the loop will work. Why? Because left is at 0 and right is at the last point at the index 78. So after this, how binary search works is simple. So find a data called mid. Mid in the sense, keeping left and right point, we are trying to find where is the midpoint, where will be the midpoint is present. Why midpoint in the sense, we are trying to split this array into two equal parts so that we'll be able to search in either left side or either right side instead of searching for the entire array. So now, how do you find the midpoint keeping left and right pointer is simple. That is add left and add right and divide that array by 2. Done. So that will give you a midpoint initially. So now let's just say that, so according to our size, left is at 0 and right is at going to be, see, left is at 0, right is going to be 1, 2, 3, 4, 5 and 6, which means that I'm trying to divide 0 plus 6, that is going to become 6, and divided by 2, that will give you the index value 3. Index value 3. So mid index at the midpoint value, which is the index value 3. At the third index, I have the data 5. You can see a third index data is already present. 5 is the data that we are trying to search for, but 5 is already present, but it's not the first occurrence. So now what you need to do is check whether the data is present or not. Because we got third index, right? We are trying to split the array into two parts. We got the middle index. Check whether that middle index, so that list of that mid index is matches my search data, which is going to be your k data. So if it matches, immediately we'll return the answer because we found the matching case. But the question says we need to find the first occurrence. First occurrence is happening in second index, not in the third index. So what we're gonna do is, so the data is matching, but it is not the first occurrence, which means that after this, you need to pay attention like what is happening, right? Like what is going to happen now. So let's take our result value, which is initially, I'm going to give it as -1 because that's where I'm trying to calculate the result. So whenever the data is present, what I'll do is immediately update it. So result I'm going to take it. We don't need the data, we need the index value. So index value, I'm going to update it mid. So far our mid index is 3. Data is present. We are trying to go to the midpoint of both left and right. I went to the midpoint, and then that midpoint, the data is present. Now, once the data is present, what I'm trying to do is, initially I'm keeping the result as -1. Why? Because if the data is not present at all, the result is going to be as -1. But if the data is present, that index updated. So that index value, which is 3, that we got from this one, 0, 1, 6, which we got 3, I'm going to update it as my result. So that's it. The program is done. Now, in case if it is not present, let's say this data is not present. So instead of 5, we have some other data, which is 10. So as we know, the data is already sorted, which means that the lesser data will be present in the left side and the higher data will be present in the right side. We are just assuming the data is going to be 10. So in this case, what happens? Your if condition doesn't work because the data present is 10, which is not your k value. It doesn't matches. So it's not going to work. So what do you need to do? You're going to split this array into left and right. So what happens? This array midpoint doesn't matches, which means that the k value that I'm trying to search is going to be in the left side. Why? Because that is lesser than the mid data, which is 10. So what happens? I'm going to split this into two parts. I'll split this separately and I'll split this separately. So left pointer was over here. Here I got left pointer. Okay, let me write it left. And here I got right pointer. Like initially, right pointer is at the last index. Now mid pointer is over this point. So let me write mid. Right is at the end. So we found out mid is 10. So 10 doesn't matches with the k data that I'm trying to search. If it matches, I'm just taking the mid data and I'm storing it in this set because we need that index value. If it doesn't matches, what we need to do is, we know that if the data is lesser, it will be present over here. If the data is higher, it will be present over this side. So now the data is going to be less, which means that write the condition for both those conditions. I mean, write the condition for whether should I go to the left part or should I go to the right part. So if you go to the right part, what happens? Let's try with this one. So let's say we are trying to search for 5, right? So 5, we've got over here. So now we know 5 is going to be less. So these 3 are the data that I'm trying to search for. We don't need to worry about the higher data because the data is not going to present in that one because the 5k data we are trying to search is going to be in this one, which means that the current left is over this and the current right is pointing towards the end. Now what you need to do is create a new subarray where your right pointer should be pointing over here. So this will become your new array for your next loop. Now your right is over here. I found the midpoint and the data that I'm trying to search is lesser than the midpoint. So what I need to do is I should make sure this right, this from here, from the last index, I should make sure it is pointing towards my the subarray, the left part of my subarray. So how can you get that data? How can you initialize this to point towards the left subarray, which contains only these three data? So what you're going to do is we'll write the next condition for lesser data and higher data because array needs to be splitted in left or right. So okay, indentation is okay. LF. Check whether the list of that mid value. What's my mid value so far? Mid index is 3. So if you have a greater value in that, we need to go to left side or we need to go to right side. Now let's just say this mid value is lesser than the search data. Then what happens? We need to split the array. If it is lesser, what happens? We need to go towards the right side. And let me have another condition. So tab. Left. Check again, compare with mid, whether the key data is lesser or higher. Okay, done. So once this is done, so if it is lesser, what I'll do is if it is greater, I'll make right to point towards this. If it is lesser, if the mid data is lesser, then I'll make this left pointer to point towards this. Because this is going to be your new array if the data is greater, and this is going to be your next new array in your next loop if the data is lesser. So according to the condition, I'll write left. So initialize. So how can you make this left to point towards this is we have based on your mid pointer because we got our mid pointer over here. So mid pointer plus 1 will be this index and mid pointer minus 1 will be this index. So accordingly, left and right, store it. So I'm going to store mid plus 1 and right, store it mid minus 1. Simple. So based on higher data or lesser data, you can just calculate this. So let me just make this as comment. So I'm going to give the same data because the code will give you whether the search is, whether the data is present or not. But yet we did not write the code for finding the, finding the first occurrence, first index value. So let me give these inputs. So 1, 2, 5, 5, and 5, 56, and then 78. So these are all my array data. Done. And the search element was 5. Done. Hold on, it's still reading for your input. Okay, I'm supposed to return something. Sorry. I need to print the data. Okay, whatever the answer. Okay. I was checking for like case of errors or not. So now this is your code for binary search, but we need to find the first occurrence. So whenever the data is occurring over here, we'll take that index and we will store it, but we are not optimizing it so that it will search for the friend. So now what happens? Let's go back to our original data, which is 5. So now what happens? 5 is present. Immediately your if condition will become true and that index will be stored in your result. And then what happens? If 5 is present over here, 5 might also be present over this part also. Because 5 is present over in the sense we are not checking for the last occurrence. Last occurrence in the sense you need to move towards this side. But we are checking for first occurrence. So I'm going to move towards this side, one by one. So now what happens? 5 is present. there's a chance that 5 will be present over this part also forward. And also if you have another 5, then again 5 will be present in the forward. So whenever the data is present, take that mid and store it, and now check for the previous data whether the 5 is present or not. Again check for the previous data whether the 5 is present or not. Again check, because first occurrence, this data also might be 5. So again, whenever the data is matching, previous index, previous index, previous index, just go for previous index and check those data. Okay. So the code is not completed. If it is a binary search, the code will be completed. Now what happens? I told you, right? Like 5 is present. So check the previous one. So in your next iteration, this is supposed to be your next following loop. So what I'll do is I'll update my write as mid -1. Done. So what happens once this is done? So now third index will be matched, and then that index will be stored as your result. So result will be updated with your mid value, which is 3. And now again, I'm assigning right as mid -1. So why am I doing this? This is present over here. So immediately what I'm trying to do, I'm taking this right, and I'm taking the mid -1, and I'm moving my right towards this point, towards this index, which is going to be mid -1, because 5 might be present in this one also. So now your new left and right is this one in your second loop. So left is this, right is this, still left is lesser than right. Again, I'll take the midpoint. So for these two, my midpoint would be this. Now I'm checking whether midpoint is present or not. So again, you can see that midpoint is still present, which is going to be 5. Now what happens? This midpoint, still 5 is present, right? So that doesn't mean that this is your first occurrence. Still this might be your first occurrence. So what I'll do, again, I'll assign left and right towards this index until both becomes equal. So once it becomes equal, I'll simply return the result. So whatever the result that we calculated, return it. Okay, something is happening. Let me just clear the indent. Because I was just writing all those numbers on the top, these numbers. Because of that, my indentation is gone. So this result has been returned. So this go for printing whatever the result that you got. So let me check this. So now same input. Let me give 1, 2, 5, 5, 5, followed by 56 and followed by 78. So the input, the sample test case is given over 1, 2, 5, 5, 56, and 78. So these are your list element, and then I'm going to give 5, which is the element that I'm trying to search, and then I'm running it. So it says 2. 2 is the index where the data is present. So have a look at it. Like same binary search. If I remove this one, if I remove this particular line, it will become binary search. You are trying to find the mid value. If it is matches, take it and store it and return it. If not, go to the right side. If not, go to the left side. But because of this first occurrence and because of the time complexity, it tells that it's supposed to be in n log n, right? So that's for that reason, we need to make sure like every time the data is present doesn't mean that that's the first occurrence. So what you need to do, again, reduce your pointer by 1. Check whether the data is present or not. If not, it will be remain as 3. But if the data is present, your index will move to 2 and move to 1. It just goes on reducing until the first occurrence of 5 is present. If in this case, if I have 1 instead of 5, so now what happens? Initial mid value is going to be 3. That value will be updated, and right is being assigned with mid minus 1. So right will be assigned to this index. Again, 5 is present. So what happens? Again, your loop will run. Again, for this, we want to find the mid value, whether 5 is present or not. Now, again, the mid value is present in your second loop. So that mid value, the index 1 will be assigned to result. Again, I'm reducing it because it might be present in this first index also. So that's the reason we need to write this extra line where you need to reduce the right side also because of the first occurrence. Okay, fine. So just leave out these comment parts. You don't need to worry about it. So yeah, take a look at it. In a minute, we'll go to the next one. Okay, so let me just take the code out and then leaving the side if I go for download. Let me try downloading it. Okay. This is your next question. So take a minute to read through it. So once you understand your question, it will be easy to code. Okay, let me read this. So given current situation, John is in. Can you help him to figure out a solution? Fine. So John is trying to find the numbers which are surrounded by prime numbers. So okay, by this we can already understand what's the program is going to be. So you're given a set of numbers. In those set of numbers, you're trying to find the number which is surrounded by prime numbers. So this is just an 1D array. You don't need to worry about like finding up or down, because when you get a 2D array, then we have a problem because we have 4 directions: up, down, left, and right. 4 directions will be surrounded by prime number, but this is one dimension. So all we need to check is whether for I plus one or I minus one given I data. So I data might be anything. For example, I data might be 3. How do you know whether this is surrounded by prime numbers or not? This 2 and this 4. So if you take 3 as your current I data, so your iteration will be just running from starting to end. So if this is your I data, I minus 1 and I plus 1 supposed to be your prime number. If that is a prime number, all you need to do is just increment your count, which means one prime number is present. Okay, and a number is said to be John's favorite number. It is surrounded by prime numbers. So number X is John's favorite if it falls in a pattern like so: P, X, and P. They also told that surrounded by prime numbers, and also they've given the pattern which is P, X, P, which means which indicates this is the x value is trying to find, and p indicates prime, and another p indicates prime. So this is the pattern which he is trying to find, which means this is supposed to be an x value. Like this is going to be his favorite number. If this is a prime, and the next number I minus 1, I plus 1, if both are prime. Fine. So let's check for complexity still. Okay, John to give the total number of such numbers. Just need to print the count of those numbers. So we don't need to print the data. We just need to print how many numbers are present like that. So input array, first array is given, second array is given. So now it says first input says 1, 2, 3, 4, 5, and the output is 1. Why? Because there is only one number 4, which is surrounded by prime numbers 5 and 3. Talk about 1, it's not surrounded, and you don't need to worry about first and last. Why you don't need to worry about first and last? The pattern says the x supposed to be present in middle of p. So the pattern is supposed to be like this: p, x, and p, which means you don't need to worry about first and last numbers, because first and last is not surrounded. X should be like, we should have a number before, and also we should have a number after, which means we need to worry about only these three numbers, 2, 3, and 4, because we don't need to worry about that one, because of the question says p, x, p. X should be in the middle, and both should be at left and right. So fine. So for this, let's take an array. So let me make it as comment. Okay, the first thing that you need to do is read your input. So input says that you just given a set of numbers. You don't need to worry about size or anything. Same thing. So create an array. This time I'm just calling it as an array. So get your input, and input is going to be your split input, because we have more than one input. And that split input is not just a string. If you just leave it as like this, it's going to take it as a string. That is going to be an integer. So map it into integer. So I'm trying to map this into an integer input dot split, which means that if I give 1, 2, 3, 4, that will be stored in AR. But AR is not a single variable. We are trying to store multiple variables. So I need to cast it into a list. Fine. I'm getting my input and I'm splitting it. So now the input has been splitted into separate parts. And then those data type are still in string data type. So map it into integer data type and then cast it into a list. So array will become list. So let me just try printing this. So I'm trying to print AR. So what this prints is like I'm giving 1, 2, 3, 4, some number with space in between. So if this is your input and I'm printing it, you can see it says 1, 2, 3, 4. So what happens? All these data get splitted and get stored in form of a list. So now, so let's call for solution. You can directly call for solution. So print, call for a method called solution. I'm just naming the method as solution, and I'm passing my array. Fine. So let's start defining my solution, which will accept one data. I'm passing array, that data accepted. Now we need to find not the data, we need to find the number of count. How many count are present? So for that we need a variable. So I'm going to write initial count is going to be 0. Done. And when you look at your array data, let me just take this. Okay, this is my array data. So as I told you, the pattern is supposed to be this. It is supposed to be in the middle, not in the edge, which means that we don't need to worry about first and last data. We don't need to worry about that. We need to find whether these three numbers, among these three numbers, how many numbers are surrounded by your prime, which means that you can just start running your loop. From this point, I'm just going to start my loop for okay, for I in range. This range doesn't start from 0. It's going to start from 1, and it's supposed to stop at length of array minus 1. Simple. So this will run your loop only for these data, 2, 3, and 4. I'm starting from 1 and I'm stopping at length of array, which is going to be 5 minus 1, which will stop at third index, because this will run for. If this data is 1 and this data, let's say this index data is going to be 4. So it's going to run for 1, 2, and 3, less than, always less than the last data. So for this, what are all the index value which is calculated based on your size? For this, your size is going to be 5, which means that I'm running 5 minus 1, which is going to give you 4. So what are all the elements that is going to run in this loop? Loop is going to be 1, 2, and 3. Those index value. Only those index value will be running in this loop. For those index values, all we need to do is check for condition. So I'm going to call if. We need to write another method or another function to know whether a particular number is prime or not. So what are all the numbers supposed to be prime? So initially I'll be checking for 2. So 2 is your I data. So all you need to do is check whether I minus 1 and I plus 1 data, or these data are prime or not. So I'm going to call this for another function is prime. So I'm going to pass I minus 1 and say method I'm going to pass I plus 1. So if I minus 1 for your current I value is starting from 1. For this 1, 2, I minus 1 is going to be 1 and I plus 1 is going to be 3. If these two data are prime in the sense, all we need to do is increment your count. So count plus equal to 1. Count will be incremented whenever your condition matches, which is being the prime number. And then once your code is done, all you need to do is return whatever the count that I have calculated. So I'm going to return count. So if I let's just say that they did not mention, as in previous question they mentioned you are supposed to print minus 1. That's why I initialized the result value as minus 1 initially. But in this case, they did not mention about anything being minus 1. If no data is present, if no such cases are present, you need to print minus 1. They did not mention anything about it, which means that by default it's going to be 0. So that's why I'm writing the count as 0. If no such values are present in the sense, TXP, if no numbers is surrounded by prime numbers in the sense, by default it's going to return 0. Because it does, like question did not say you need to return minus 1. So now all you need to write is prime number code. So I'm gonna write another method calling for is prime. So I'm gonna pass a data, like whatever the data that you're passing, I minus 1 data, I minus plus 1 data. So this data, I'm taking it as n. And also I should make sure whether is prime is an inbuilt function, because if this is prime is an inbuilt function in the sense, my code is not going to work. Or let me do this. Let me give an underscore. Because by default, we have so many inbuilt functions. Why am I writing that is because we can see that the color is changing. So that's the reason I'm just giving an underscore. Now, look, that's a usual practice. If you want to go with this prime, fine. You can do it. It still works. So now, prime number code, simple. If n is less than 2, either return true or false, because this if condition is based on Boolean value because of and, either true or false. So if it is less than 2, we not even calculate. So I'm going to return false. Sorry, with the capital. Done. Now what you're going to do is run a loop. Whenever the number gets divided by 2 in the sense, immediately return false. Because all right, all the false condition first and write the true condition first. Right? What is the prime number? The number shouldn't be divisible when you just run it in a loop. So let me run a loop for I in range starting from 2 because less than 2 already I'm returning 0 and it runs for n times. Fine. You can write it for n times, or if you want, you can just apply square root because that would be optimized, or you can run it for n divided by 2 times. That is to optimize your loop for finding prime numbers. So run it till n times or n divided by 2 times, or you can run it for square root. So if you want to square it, just n to the power of 0.5 and cast it into integer because 0.5 will give you a floating point. So plus 1. Why plus 1 in the sense? Because always loop runs with less than. It's not less than equal to. The condition is less than. So that's why I'm giving plus 1. I can run it for n times or n divided by 2 times or root of n times. So while running for these datas, check the value n gets divided by any of these I values. Because I value is going to run from 2, 3, 4, 5, 6 like that. But n shouldn't be divisible. But if it is divisible, it's not a prime number. So return false. So if these two false condition doesn't work in the sense, obviously we know that it's going to be a prime. So I'm going to return true. Done. So we are getting an input. I'm trying to call for solution function. So solution function, initial count is going to be 0. Once the count is done, I'm trying to return count. That will be printed in line number 35 because I'm trying to print the value whichever is getting returned. And for this, I'm running my loop from 1 to I minus 1 because we don't need to worry about first data and last data. We need to worry about only the data which is in middle. And now, for particular I data, check whether I minus 1 and I plus 1 both are going to be a prime. If both are prime, then count gets incremented and we have our prime number code over here. So let's take in the same input 1, 2, 3, 4, 5. So I'm going to run it. Sorry about that. I in range 1, 2, 3, 4, 5. Done. Okay, fine. It says 0. My count supposed to be 1. Okay, just give me a minute while I'll check for the code. Sorry, I'm just passing the index value and trying to find whether the data is prime or not. The mistake that I run is this one. We are supposed to check whether the array data that I'm passing, not the index data. So I'm supposed to pass array. So let's try this again. Because previously I was passing only the index value. I was passing 0 and 3 and 1, those index values. But we don't need index, we need data in that particular index. So let me give the same input. Okay, fine. Now your output is 1. So let me just try with different test cases. Give 4 and then 5, 6, 7. So now we can say that, sorry, 6 is surrounded by 2 prime numbers, which is going to be 5 and 7. So now again your count is 1. Okay, just take a look at it. Fine. Now let's just go to the next question. Okay, this is the question number 3. So, okay, let me just read it out. So, given a classroom where students have appeared for an exam, you are the invigilator for the exam. So now you are responsible for ranking the students based on their marks. Okay, you need to rank the students based on their marks. The marks are given in the form of array. Same is going to be a split input, which means you need to map it into an integer and convert it into a list. And then you have to simply sort the marks based on the specific system. There is a like you need to sort the array, but with a given condition. The special system says that firstly, the marks which are even will appear in the sorted order, and then odd will be appearing. So, which means that we got an array, and this you need to sort it accordingly, which means like accordingly, so that even numbers will be sorted first, followed by odd numbers in the next. So that's the output which is given over here. So this is the given input. You can see first two inputs are even numbers. So even numbers in sorted manner, which we have 4 and 56, followed by odd numbers, which is 1, 3, and 77. So after that, there is no note and there is no time complexity, and note is given over here. Mm, order of the sorting supposed to be in ascending order. The even number comes first, followed by odd numbers. Fine. So there is no trick here. Like direct number, all you need to do is sort the even numbers first and then sort the odd numbers first. So we'll be creating two arrays. One array we'll be calling it as even, the other array we'll be calling it as odd. So we'll be creating two like even array and an odd array. So even array sort all the even numbers first. Odd array sort all the odd numbers first, and then all you need to do is join both the array together and return the answer. Fine. Let's see how to do this. So let me just make the question as comment. Right, in a given list, sort the even numbers first, followed by odd numbers next. So I'm going to scan the input. Let's call it as array. This is going to be an input, a split input. And this supposed to be mapped into an integer. So I'm mapping it to an integer. and that should be cast into a list. Done. So read all your inputs, and then I'm going to call for solution. So I'm just calling for solution, and I'm just passing my array data alone. So now let me define my solution where I'll be accepting all the array data that I've passed from my main. So we have a number of ways to sort this. You can just sort it in a single line, or you can just create two empty list, and then you can run your loop one by one by one by one by one. And if it is even number, join it with even list. If it is odd number, you can join it with odd list. Or you can just run it in a single line code. Okay, let's go with a single line code because that's easier. So let's take even and another variable odd. So you could use the keyword sorted, because that is going to give you the data that you're trying to take will be sorted, and that will be stored in even. So what are all the data that I'm trying to sort? That we need to specify. So sort all the numbers for number in array. Simple. What I'm trying to do is, okay, it's a square bracket. I'm trying to sort the numbers for numbers in array, which means I'm going to take all the data in array one by one, and those data is going to iterate through the variable called number. And we can write the condition here, the same condition. So sort all these data only if that number, sorry, what? Yeah, only if that number is divisible by 2. So modulo by 2 supposed to be 2 equal to 0. Simple. So that you don't need to run a loop separately, or you can just create an empty list and you can run your loop one by one, odd number, odd list, even list. So again, same, do it for odd. So we have same number for number in array if instead of odd number, I mean even number, we're going to take it as odd, not equal to 0. Done. So now you can just return these two data, or you can print it in the same data. You can just return, or you can just try printing it. So let me try printing this. Okay, we need to join it. So first I'll join this. So I'll create another variable that's called result. So in result, join even, because first even followed by odd. And then let me try printing it. So print res. Okay, let me give the input which is given over. Let's take the same data 3, 1, 4, 56, and 77. Fine. So we got our output, but if you do this, it will be accepted. It will be accepted, and your code will be executed. Even though you have comma and you have square brackets, it will be accepted. But if you don't want that, if you don't want this comma and if you don't want this square brackets, then what you need to do is you need to convert this into a string. So how are you going to convert this into a string is maintain an empty string. With that empty string, join let's just say result. But we need to cast it because result is a list. and we are trying to join it with a string. So how we're going to do is map it. I'm trying to map this into a string and close your bracket. So with an empty string, I'm trying to join something. What I'm trying to join? I'm trying to join the result. But that result is a string data type. So that's why I'm writing it as str. Map it into a string and let's see whether this works. So now we got all the data without getting any spaces or without any, I mean, without the square bracket and without the spaces. Okay, so just take a look at the code and see whether you can understand what's happening. Okay, fine. So you'll be like, we'll be doing more codings in upcoming sessions, and yeah, and it's going to follow for next 12 days. We'll try to cover up as much as questions possible, revise through all the difficult as well as like from beginning level to difficult level. And that's it. That's it for today. And if you like this video, please share, like, and subscribe. So thank you for joining, and that's it.